Hi guys, you are welcome to my class. Today we continue the chemical properties of alkanoic acid. In my last video, I've explained acidic properties of alkanoic acid, where we have ionization of alkanoic acid in water, reaction between alkanoic acid and highly electropositive metals, reaction between alkanoic acid and thiazocarbonate 4 compounds, then reaction between alkanoic acid and alkanol, which is known as esterification reaction. So number two now is what? Combustion reaction. So in today's topic, we are going to look at combustion reaction of alkanoic acid, reaction between alkanoic acid and phosphorus 5 chloride and thionyl chloride. Then substitution of alkanoic acid with halogens. Then lastly, we talk about reduction reaction of alkanoic acid with powerful reducing agents. So let's begin with combustion of alkanoic acid. Combustion reaction. Then what is the word combustion? Combustion means burning of substance in air or oxygen. Burning of substance in air or oxygen. So when alkanoic burns in air or oxygen, it produces carbon 4 oxide and water. It produces carbon 4 oxide and water. So it shows that reaction between an alkanoic and oxygen will give us carbon 4 oxide and water vapor. So let's look at chemical reaction for that. Let's start with general formula, which is RCOOH plus oxygen. Then this combustion reaction is common to all organic compounds. Combustion reaction is what? Is a chemical reaction that is common to all organic compounds. Then when any organic compounds react with oxygen, your product will be what? Carbon 4 oxide and what? And water. Carbon 4 oxide and water. So let's take a named alkanoid. Let's take ethanoic acid. Ethanoic acid, which is CH3 COOH plus oxygen. Your product will be what? Any organic compound, not only alkanoic acid. Whenever any organic compound reacts with oxygen, your product will be what? Carbon 4 oxide and what? And water. So the only thing that you need to do is what? To balance your chemical equation. You balance your equation. Now, this side, we have two carbon atoms. Two carbon, then we have one carbon atom here. You put two here to balance the number of carbon atoms at the product side. Then four hydrogen atoms at this side. Four hydrogen atoms at this side. Then we have two hydrogen atoms at this side. So add two here. 2 times 2 will give you 4. So hydrogen atom is balanced. So let's calculate the number of oxygen that we have at both sides. At the reactant side, we have 2 here plus 2. That is 4. 2 times 4, yeah, that's 4. 4 plus 2, that is 6. So we have 6 at this side. So we have 4 at this side. Though we balance it with 2. We balance this side with 2. So 2 times 2 is 4. 4 plus 2 will give us 6. Then 2 times 2 is 4. 4 plus 2 will give us what? Will give us 6. So our product is balanced. Just have it at the back of your mind that whenever any organic compound reacts with oxygen, your product will be what? Carbon 4 oxide and water vapor. So number 3 now is what? Reaction with phosphorus 5 chloride. Reaction with phosphorus 5 chloride. Or thionyl chloride. PCl5 is called phosphorus 5 chloride. While SOCl2 is called thionyl chloride. Thionyl chloride. So when phosphorus 5 chloride and thionyl chloride react with alkanoic, a product called alkanoli is formed. It forms to produce alkanol. So to produce alkanol. So alkanol will be formed. So whenever phosphorus 5 chloride or cyanide chloride reacts with what? With alkanoic acid. So let's write chemical reaction for this. Reaction between alkanoic acid. I'm going to use general formula first. RCOOH. RCOH plus PCl5. So what will happen is that the hydroxy group from the carbonyl group will be displaced. So you displace the hydroxy group. Let me explain with structural formula. So this hydroxy group will be displaced. Then one chlorine what? One chlorine atom will occupy the position of this hydroxy group. So one chlorine atom will be released from here, Cl. So the Cl will now occupy the position of this hydroxy group. So from here now, we are going to have RCO, because we have removed, you remove this hydroxy group, then you replace with what? With chlorine atom. So it will give you RCOCl plus then the hydroxy group now, the hydroxy group will decompose to hydrogen and what? And oxygen. Hydrogen and oxygen. Don't forget that from here we have used what? We have used one chlorine. We are left with what? We are left with PCl4. So one of the hydrogen we also combine with what? With one of the chlorine we also combine with hydrogen to give us what? HCl. HCl. So the phosphorus and the remaining three chlorine will combine with oxygen to give us POCl3. POCl3. So the name of the product form is called what? Alkanoic. Alka al alkanoid. Alkanoid what? Chloride. Alkanoid chloride. Then hydrogen chloride gas. Hydrogen chloride and what? And phosphorus oxychloride. Phosphorus oxychloride. So those are the products formed. So let's use a named alkanoic. Let's use a named alkanoic. Let's use ethanoic. Ethanoic, which is CH3 COOH plus, let me first react with what? Phosphorus 5 chloride, which is PCl5. PCl5 to give us what? Then the hydroxy group will be released. So the hydroxy group will be released. Then one chlorine atom Cl, then we join with what? We join with CH3COO to give us CH3COCl. CH3COCl. Then the hydroxy group will decompose to hydrogen and what? And oxygen. So one of the chlorine we also combine with what? With H to give us what? HCl. HCl. So the remaining three chlorine and PCl3 we now combine with oxygen to give us what? POCl3. So what is the product form now? What is the product form? 1, 2. That is the second member. We call it what? Ethanoyl what? Chloride. Ethanoid chloride. Then hydrogen chloride gas, and phosphorus oxychloride. Phosphorus oxychloride. chloride. So let's take reaction between thionyl chloride and alkanoic acid. Let's see our chemical reaction between thionyl chloride and alkanoic acid. Ethanoic acid plus thionyl chloride, that's plus SOCl2. SOCl2. So the hydroxy ion will be displaced. The hydroxy ion will be displaced. Then one chlorine will what? Will come in. One chlorine atom will come in to give us CH3 COCl. CH3 COCl. So the other chlorine, since we are having two chlorine now, then the hydroxy group will decompose into two. The hydroxy group will decompose into two. Then the second chlorine will combine with what? With hydrogen to give us what? To give us HCl. HCl. Then the oxygen will combine with SO. Oxygen will combine with SO to give us what? SO2. So that's sulfur 4 oxide to give us sulfur 4 oxide. So our product form is called what? Is called ethanol what? Chloride. Ethanol chloride, hydrogen chloride gas, and what? Sulfur 4 oxide. Sulfur 4 oxide. So that is reaction between uh, thionyl chloride and alkanoic acid. So let's move to substitution reaction. Substitution reaction. So the next one is number 4. Substitution reaction. So the substitution reaction with halogens. With halogens. With halogens in the presence of in the presence of sunlight. So the substitution reaction will take place in the presence of what? Of sunlight. So let's see the chemical reaction between alkanoic acid, and halogens. Alkanoic acid and halogen. I'm going to use a named alkanoic acid, that's ethanoic acid, CH3COOH, plus what? Plus halogen. Let's take chlorine for example, plus halogen. Chlorine for example. Then this chemical reaction will take place, the substitution will take place on the carbon atom that is next to the carboxyl group. So this time around, there will be no what? Displacement of hydrogen. There will be no displacement of hydrogen from the carboxylic group. So the reaction will take place, the substitution reaction will take place on the carbon atom that is next to the what? To the carboxylic group. So it shows that the chlorine atoms will attach to the carbon atom next to the what? To the carboxylic group. The chlorine will attach to the carbon atom next to the carboxylic group. And let's see the chemical reaction for that. I'm going to explain with structural formula. The first carbon atom with three hydrogen atoms. Then followed by the second carbon atom, which is your carboxyl group, which will be double bonded with oxygen and hydroxy ion. So the chlorine will displace hydrogen from the carbon atom next to the what? Carboxyl group. So this chlorine will not affect the carboxyl group. It will not affect the carboxyl group. Then it will displace hydrogen from the carbon atom that is next to this carboxyl group. And those chlorine will occupy the position of what? Of hydrogen. So our first chemical product will be, this one will first displace, it will displace one hydrogen, one chlorine. One of the chlorine will displace one hydrogen. So when it displace one hydrogen, then one chlorine will come in. So our product will now be CH2. We have removed one hydrogen. Now you remove this one hydrogen, so hydrogen will combine with what? With one of the chlorine to give us HCl. Then the second chlorine will now occupy the position of this hydrogen to give us CH2, CH2Cl, then COOH. So that is the product, the first product form. So you continue adding what? Your chlorine until hydrogen is totally displaced. Until hydrogen is totally displaced from the carbon atom next to your carboxyl group. Next to your carboxyl group. So our product form here, you take your product form again, which is CH2 Cl COOH plus Cl2 again. So another hydrogen will be removed. Now remove one hydrogen from here. Remove one hydrogen. So we'll be left with what? One hydrogen, CH. Remove one hydrogen, then bring one chlorine in. So when one chlorine comes in, that is, bring one chlorine in, we give you two chlorine. So Cl2, then COOH. Then the second chlorine will now combine with this hydrogen to give you what? HCl. So you take your product again, your product form again. Then don't forget that this chemical reaction will take place in the presence of what? Of sunlight. So your product form here again, that is CH, you take your product form CHCl2 COOH plus another chlorine. Then you displace the last hydrogen. You displace the last hydrogen from here and chlorine will come in. So remove one hydrogen and let chlorine come in. Then this chlorine will combine with the second what? The hydrogen will combine with the second chlorine. So when you remove one hydrogen here, you will be left with C. Then chlorine will come in, making how many chlorine? Plus these two chlorine will give us three chlorine. That's Cl3, then COOH plus what? Plus HCl. Plus HCl. So that is the chemical reaction between the substitution reaction between alkanoic acid and halogen. Substitution reaction between alkanoic acid and halogen. So let's take the last chemical reaction, other chemical properties of alkanoic acid. So the last chemical reaction is what? Is reduction reaction. So the reduction reaction will take place in the presence of strong reducing agents. Reduction reaction will take place in the presence of in the presence of powerful reducing agents, so such as lithium aluminium tetrahalide. So we use lithium aluminium tetrahalide as our reducing agent. So let's take an alkanoic acid. I'll first use the general formula, which is RCOOH plus lithium aluminium tetrahalide. Then what is reduction? Reduction is what? Addition of hydrogen. Reduction means addition of hydrogen. So hydrogen will be added from our reducing agent. Since reduction is addition of hydrogen, so the hydrogen is taken from the what? From our reducing agent, that is from this lithium aluminium tetrahalide. We are using the hydrogen from our reducing agent. So let's see how we are going to form the product. I will use the structural formula to explain. Now, the double bond from the carbonyl compound, from the carbonyl carbon atom will break. So this double bond will break. So when this double bond breaks, two of this hydrogen will react with oxygen. Two hydrogen will react with oxygen to give you water molecule. Two hydrogen atom will react with oxygen. So when the double bond breaks, so what we are going to get is RC, then the hydroxy group, which is OH. So this double bond will now split. Since we have displaced oxygen now, we have removed oxygen. So the double bond will open, will split into one here, then the another bond, the second bond here. So two of the hydrogen will now combine, two hydrogen will combine with this carbon atom to give us HH. So we have formed the what? We have formed an alkanol. An alkanol. So it shows that when alkanoic acid undergo what? Reduction, the product form will be what? Will be an alkanol and water and H2O. So our product is now RCH2OH. Then plus what? Plus H2O. RCH2OH plus H2O. So let's use an alkanoic member. Let's use an alkanoic member of alkanoic, like ethanoic, or we use propanoic acid, which is C2H5COOH. C2H5COOH plus what? Plus hydrogen from our reducing agent. Plus hydrogen from your reducing agent. Then your reducing agent is what? Is lithium aluminium tetrahalide. So this hydrogen is coming from this reducing agent. So let's use structural formula to form our products. We have C2H5, then C double bond O, then OH. So the double bond will what? Will break. The double bond will break, then oxygen will be released. Then two hydrogen atoms will combine with oxygen, and the other two hydrogen atoms will combine with carbon atoms. So when two hydrogen atoms combine with oxygen, let's first take the first product, C2H5, then then this double bond, since we have released oxygen, so double bond will break. So the double bond will be splitted into two, then followed by what? Our hydroxy ion. So the two hydrogens atoms here will come in. One will attach to this bond, the other will attach to the second chemical bond. So the oxygen now will combine with the remaining two hydrogen atoms to give us what? Water molecule plus what? Plus H2O to give us water, a molecule of water. A molecule of water. So our product form is now two carbon atom, three carbon. That will be the third member of alkanol. Third member of alkanol. And the third member of alkanol is called what? Propanol. Propanol. So you can rewrite your chemical equation in this form, that is C2H5COOH plus your reducing agent, hydrogen from your reducing agent, then in the presence of your lithium aluminum tetrahalide. So your product form will now be C2H5. So the second carbon atom with two hydrogen, that's C2. The second carbon atom, that's CH2OH. Or three carbon atoms, that's C3. 2 here plus 1, that's 3. 5 hydrogen plus 2 hydrogen atoms here will give us 7. So C3H7OH. So our product form is what? Is propanol and water. Propanol and water. So we have come to the end of today's class. Share this video with your friends.